Thanks very much. So, what I'd like to do is basically, before I sort of get into some of the things that we at Omniperception get up to, essentially we are experts in two fields. Firstly, face recognition, which is very exciting, but unfortunately will not feature at all in this presentation at all. But the other thing we do is object recognition. And object recognition is really part of a kind of more general video analytics. And in preparing this talk, I really started to think about really where video analytics came from and then where is it going. And the more I looked and thought about video analytics, and I've sort of categorized some of the things that are available nowadays, there's a whole wide range of applications. I'm sure your favorite application for video analytics is not on the screen there, but there's a whole host of them. But for me, there's a very common theme in that certainly traditionally video analytics in terms of loitering detection, perimeter detection, they started because we wanted to do things that human beings are bad at. Fundamentally, we're not particularly good at looking at video, trying to detect particular occurrences. We are expensive, we get bored very quickly, we get distracted, and generally we fail at it. And I think this has really led in many years ago to the increased sort of deployment of video analytics to fundamentally codify what a human being would do. And that underpins actually most of the things which are on that slide, which is that they're to codify what a human being could otherwise do. And in fact, the company that, you do have to press it firmly, the company that I work for, we evolved in exactly that way. We started off as a small spin-out from university, and about 4 or 5 years ago, we were approached by a particular marketing research agency, actually, who said, we know you do video analytics. Can you identify brands on a TV broadcast? And they then explained how a particular advertiser used to record the amount of exposure they had on sporting events. And even 4 or 5 years ago, if you sponsored a football team or an event, cricket match, football match, if you sponsored a particular hoarding or a shirt on a player and you wanted to know how much exposure you got for your money, then the way that would be done, even 4 or 5 years ago, it's quite astonishing, was that people would sit down, they would look at the broadcast stream, and they would have a stopwatch in their hand. And they would actually count the number of seconds that were on the screen. It's completely unbelievable. So we recognized there was a market, and we started to take our video analytics and move it into that space to a point where today we are basically analyzing virtually every sporting event you can think of, and many of you will not have any idea about, like Norwegian horse trotting, if you're into that. We analyze that, but the Olympics, IPL, NASCAR, all these types of TV broadcasts are analyzed by our footage in order to automatically determine how much exposure each of the brands have got. Just to give you a feel for what happens, I've got a short video. Before I play the video, I'll just kind of explain what's going to pop up on the screen. There's essentially 3 segments to the video. On the left-hand side are the brands that we're looking for automatically. In the middle of the screen, there's a video playing. It's actually an interview post-match at a German football match. And on that video that's playing, there are quite a few brands. Not a huge amount from our perspective, but quite a few. And when we detect those brands, we'll draw a purple box around it. And we'll also label it if it's Nike or Adidas, etc. And then the right-hand side of the screen is the brands that we have found in that frame. So once I play this video, the left-hand side stays static. The video plays in the middle with purple boxes appearing where we found brands. And the right-hand screen, the right-hand will change very quickly as each frame goes through. So I won't really talk over this. But essentially, as I say, the brands on the left are the ones we're looking for. The ones we find are purple boxes in the center. And as each frame scrolls through, the brands are located on the right-hand side. And we'll be tracking the size, the position, degree of occlusion, whether the brand is off-screen or on-screen. And we will supply that information back to market research agencies, brand owners, rights owners, in order for them to then combine it with viewing data to determine what sort of exposure they had. But as you can see, that analysis was post-event. And many of the things that I've described and some of the things that were on the first slide were all post-event. And this really underpins much of what's been said in the previous talks, in that it frankly was not possible to do the types of things that we're now speaking about because the processors were not there. They weren't powerful, and therefore a lot of the video analytics was done post-event. And on the right of the screen is actually one thing that we have done post-event, which is just helping out the police. It's a fairly standard application for video analytics, which is we were given certain footage by the police, and we were asked to locate a particular individual who was known to have committed a certain series of crimes. And we tracked that individual by his clothing, actually. He was very kind. He didn't wear a black hoodie with nothing on it. He wore a hoodie with a very distinctive pattern on the back. So we're not proving conclusively that he did the crime. We're enabling the police to chronologically fit where that person may have went. Similarly, another piece of this is actually from the London riots, unfortunately, back in August 2011. The gentleman with the yellow jacket was seen at a number of different crimes. We used video analytics post-event to piece together where that guy had been, and it allowed them to actually, in fullness of time, save a lot of time searching through video, which is really what this comes down to. But B, more importantly, he ended up in jail. So historically, many of the video analytics techniques that have been employed specifically for us on the brand recognition side have been done post-event. But as we move sort of further forward in time and algorithms become much more efficient, processors, as we've heard, become far, far, far more powerful, it allows us to start to do things in real time. And clearly, as consumers, we want information in real time. We want things in real time. We don't really want it post-event. And so what I've popped up on the screen there is a video, actually. It's a car going through Australia, Melbourne, Australia. And what we've asked it to detect is the speed signs. And as you sort of scroll along the street, you notice there's a sign which is being detected. And that information can be fed back to the car. And there are actually systems which are out there, commercially available in the US, not so much in the UK. I think there's one that's just arrived in the UK. Which do this sort of thing. So it's using video analytics in real time to assist what the driver is doing. So I've touched upon where video analytics came from, the types of things we did historically. What I'd like to do now, because I was asked to sort of cover it in the slide, is our view of where it's going and the types of things that would be possible using some video analytics in the future. So I just got a couple of slides to really describe where we see it going. But before I start out, there's a couple of things that I think have happened very recently, which mean that we are at a period in time where the expansion of video analytics in general is really there for the taking. As we've seen with a couple of the previous slides, much of the processing power is moving out of the CPU and into the GPU. And whilst the previous speakers have talked a lot about mobile phones in the sectors that we deal with, that is equally as true on CCTV and other types of edge devices. And this allows us to move some of the algorithms which have been historically based in big, powerful servers out onto the edge. We utilize bandwidth far more efficiently by doing that. And if you look at your phone, for example, a good example of how that's been integrated over the last few years is face detection, face recognition, smile detection. These are all techniques which are now widely available on devices which you hold in your hand. So that's one thing that's happened. I think the other thing that's happened with video analytic techniques is that they frankly have grown up. They have become techniques which are no longer the sort of domain of specialist companies operating in perimeter detection, crowd detection, whatever it is. They realize that they have to integrate into bigger systems. If I'm doing a face recognition, for example, It's no point in me just simply recognizing a face and telling you when a particular individual walks in a building. It's frankly useless. What I need to do is integrate with the building management system to alert that fact to you in exactly the same way as a fire alarm would go off or an intruder alert has been detected. So integration of these video analytic techniques with wider systems is something which has become much better. And I think video analytics has also got much better at managing expectations, frankly. We're not a panacea, and a few years ago, particularly in the security sector, video analytics, and we suffered from this. We were seen as a panacea, and we're damn good, but we're not perfect, unfortunately. So looking forward, I think I entitled this slide Challenges, and I think with hindsight it's actually wrong. It should be titled Opportunities, because as we've heard from a number of speakers sort of today, the amount of video and photographs that are being captured, whether it's CCTV, phones, or whatever, means that there is a mass of video-derived data being accumulated. And that, to me, is an opportunity, and that's why the slide of the title is wrong. It's not a challenge to deal with this video data. It's not a challenge to deal with the fact that we have an increasing number of pixels and data coming through. It's actually an opportunity. And there are various techniques which are coming through, and with the movement of devices onto the edge, it means that we can process that video far more efficiently. And so how do I see it in the future? I'll summarize it by giving you an analogy on text-based data and video-based data. If I look at the way that you search Google nowadays, if I wanted to look up myself on Google, I would say Stewart Hefferman, omniperception, bang. There's then a textual search which has been conducted to return some bits of information. The way I see it for video analytics, and this is not too far in the future, is that I will be able to type in, I want a bicycle crossing a bridge in London. And much of the video that will be processed as part of that search will have been automatically tagged as part of the storage. So finding the bicycle by object classification will have been done automatically. Finding the bridge, as opposed to anything else in the video, will have been done automatically. And recognizing that bridge, either itself or through GPS positioning as part of London, will be done automatically. And that's the way I see some of these techniques going, in order that we will be able to search that vast, vast, vast amount of data very efficiently and very quickly. That's all I have to say. Thank you very much.